Previously, we covered the core foundations. Now, in part 2, we tackle what is the Veil Nebula and why does it look like that? Part 2. How do we actually photograph the Veil Nebula? Nanchand Orbital Dispatch. Narration script. What is the Veil Nebula and why does it look like that? Part 2. How do we actually photograph the Veil Nebula? Welcome. In the last episode, we established what the Veil Nebula actually is. A supernova remnant roughly 2,400 light-years away, still expanding 10,000 years after the original explosion. Today, the question is a practical one. How on earth do we photograph it, and why do those images look the way they do? Intro. The veil spans about 3 degrees of sky, 6 times the width of a full moon. It's enormous in apparent size, but it's also extraordinarily faint. The gas is thin, spread across a huge area, and most of what it emits isn't white light at all. It's specific wavelengths, tied to specific atoms. That's the key to understanding how we image it. Section 1. Narrowband filters. Isolating the signal. Narrowband filters are the starting point. Instead of collecting all incoming light, they block almost everything, and only pass a very narrow slice of the spectrum, typically just a few nanometers wide. The 3 filters most commonly used on the veil are hydrogen alpha, oxygen 3, and sulphur 2. Hydrogen alpha, or HA, captures light emitted by hydrogen gas as electrons drop back to a lower energy state. It sits in the deep red part of the spectrum and tends to reveal the broad, sweeping filaments of the remnant, the shock front where the blast wave is still pushing outward. Oxygen 3, or OIIA, captures doubly ionized oxygen. It sits in the blue-green part of the spectrum and responds to regions where the gas is hotter or the shock is more energetic. In the veil, the OII signal often lines up slightly differently to the HA. You can see the 2 shells offset from each other, which reflects real physics about how the shock interacts with different layers of material. Sulphur 2, or SII, traces ionized sulfur and tends to highlight regions at the leading edge of the shock. It's dimmer than the other 2, so it takes more exposure time to bring out cleanly. Section 2. Mapping to color, the Hubble palette. Once you have 3 grayscale frames, 1 per filter, you assign each to a color channel. The most common approach is called the Hubble palette. SII goes to red, HA to green, and OII to blue. It's the same palette NASA uses for many of its own Hubble images, including the Pillars of Creation. The result is a false color image. That's not a criticism. It's an intentional choice. The colors don't represent what your eye would see. They represent which atoms are present and where. That's genuinely useful information, presented visually. Section 3. The practicalities, gear, exposure, and sky. You don't need a professional observatory to image the veil. A modest refractor, say 70 to 100 millimeters of aperture, paired with a dedicated astronomy camera and a motorized mount will get you there. What you do need is patience. Individual exposures of 5 to 10 minutes each, across several nights if necessary, are typical. Dark skies help, but narrowband filters are genuinely effective from suburban locations because they reject most light pollution. It doesn't fall within those narrow passbands. The gap between a raw, uncalibrated frame and a finished image involves calibration frames, stacking, stretching, and color balancing. Every one of those steps involves a decision, and every decision has a scientific rationale behind it. Closer. The veil doesn't look the way it does by accident. The filaments, the colors, the structure, all of it is physics, made visible through deliberate choices about light, filters, and processing. Next episode, We go further into what the veil is actually telling us about the physics of supernova remnants and what happens to the surrounding interstellar medium over thousands of years. If this kind of grounded look at how we do astronomy is useful to you, subscribing means you'll be there when the next one goes up. That is part 2 of what is the Veil Nebula and why does it look like that. In part 3, we explore the next key question. Subscribe so you do not miss it.